Hello, so here we're going to actually talk about how to draw these atoms. You know that I've done this for you a few times and want you to know how to learn how to do them. You'll need your notes as well as your periodic table. So we're just going to go through and draw some atoms. So think about a clock face. And we're going to be using the clock as pretty much a symbol of where to put certain electrons. I know that we are in a digital world and some of you guys don't use these quite often, so I just want to make sure that you see these. Let's start with the calcium atom. So let's take a look at the periodic table. Find calcium, and we note here that we have a whole bunch of different numbers in here. The upper left-hand corner tells us the atomic mass. The number to the right shows us the oxidation number, which tells us what happens with electrons. The bottom left, we have two numbers there. The absolute bottom with the dashes, that tells us the electron configuration, and the number in bold tells us the atomic number, which is actually the number of protons. So these will be really important. The bottom left-hand corner will be really important for us. So, to draw the calcium atom, we need to know how many protons and neutrons are in this atom. The protons are easy. They're going to be the number 20. It's the same thing as the atomic number. So we'll have 20 protons in the center in the nucleus. I would tell you how many neutrons there would be, or I would have you estimate them from the mass, which we'll go through a little bit later. Actually, we can go through it now. So pretty much it's going to be the mass, which is the upper left-hand corner, minus the number of protons, and it would be like the whole number. Definitely don't use a decimal for this because we can't have like 0.1 of a neutron. And we'll tell you later on in a few lessons why we have decimals in there. So to begin, we want to figure out how many electron energy levels that there are going to be. So we take a look at the period number. The period is, again, the rows. So there's 4 rows for calcium. So there's going to be 4 energy levels. So make sure you draw your energy levels. Now we need to know where to place the electrons. This is what we did back in bio as well, so some of this might be a little bit familiar, but we'll recap it. There can only be 2 electrons that fit in the first energy level. It's just too small to have any more electrons in there. So we have 2 electrons in there, and then we end up having 8 electrons in the next energy level. So drop them off at 12, 3, 6, and 9, and then drop another set off. So if you notice what we're doing here, we're dropping off an electron at 12, 3, 6, and 9. If there are more electrons that are supposed to be in there, we keep dropping them off, and then we move on to the next energy level. Now to know how many electrons will actually be in one of the energy levels, look at the bottom left-hand corner. There's 2 in the first one, that's those 2, 8 in the next one, so we drop 2 at 12, 3, 6, and 9. Another 8 in the third level, so 12, 3, 6, and 9, and then 2 more at the end, so 12 and 3. Right? So that's how you draw these atoms. So your first step is to determine the number of protons from the periodic table and put those into the nucleus. The second step is to figure out how many energy levels there are. The number of energy levels is equal to the number, or the period number, the row number. Step 3 is to put the electrons in there. The first energy level can only hold up to 2 electrons. The second can only hold up to 8 electrons. The third can hold up from 8 to 18, so it just depends on how many electrons are in there. And use your electron configuration to help you in the bottom left-hand corner of the reference table. So to summarize, protons and neutrons are going to be in the nucleus. Electrons will be in the orbitals in the energy levels. Have a great day, guys.